Hey guys, it's MJ, the student actuary, and tonight we're going to be talking about discounting and accumulating. This is chapter 5 for course CT1, and here we're actually going to get into the meat of the subject. This is something that you're going to see in the exams, and it's a very common question. And what it is they're going to give you a cash flow, but with this cash flow, the interest rate is going to be changing throughout time. So it might be 4% for the first 3 years, then 5% for the next 6 years, or it might very well be a function and you have to then work it out. So step one is you always want to figure out this is the interest rate function, what it is at the different periods of time. And remember, it's always useful to draw a timeline and just plot out all the cash flow points and all the different interest rates. Once you've got this, this is the big trick, or this is what I first struggled with, was getting that to look like this over here. So getting this stuff here into this, okay? And I'll go through just a few of the big mistakes some people make. Is, let's say they're taking something from the last time zone and they're discounting it all the way back to the present. They sometimes only use it from time 2 to time 1 instead of taking in these other values here as well. So remember, if you're going to be discounting something back 10 years and the interest rate changes halfway, you have to discount it twice, from the first interest rate and the second interest rate, not just the interest rate at the 10 years. And then the second thing is to make sure that you get these little times right. So a lot of people also, well, when I mean a lot of people, I used to make that error as well. So this is very much, these are my study notes that I used when I wrote this exam, and this is how I laid it out. Always get the interest rate function done, and then remember that you will be having a pattern that looks something like this. Don't forget to discount or accumulate by the other interest rates. And if you get that done, then this is actually quite an easy chapter as far as the theoretical knowledge goes. The application does get a little bit difficult with regards to the integration. They can make it tricky, but in the past papers that I've seen recently, it has been quite easy. So don't worry too much. If you go like quite a few years back, past papers, the integration was harder. Because basically what you have is your payment stream between two time periods and a variable interest rate. And don't learn the formulas off by heart. Know the structures, but you can always work these out in the exam. So this integral here plays on the payment stream, and then we have this integral here that works on the force of interest. And that's what E does. It's an interest that's compounding continuously. And then if it's an accumulated, now you're normally going to be discounting more than accumulating, but accumulate, it looks very, very similar. The only difference is now that the interest is a positive, or it's greater than 1 function. So this will make the payment stream larger. Whereas when you're discounting the interest rate, it's less than 1, and so it makes the payment stream smaller. And finally, what you need to realize with this chapter is you do want to brush up on your integration skills. It is a little bit mathematical when you get to this part, but that's the easy part. So when you get to the maths, that's easy, because actuaries, we're very good with maths. This is easy, child's play. This is the bit of the tricky part. It's just setting it out, laying it out, stuff like this. But do past papers. You'll see what I'm talking about with regards to this. And have a good understanding of the structure, and you should be fine with these exam questions. And yeah, that is chapter 5. We really are starting to get into the meat. Next time I'll be talking about chapter 6, which is annuities. You're going to see that cool little picture there. But anyway, that will be in the next video. Thanks for watching, guys. Cheers.